In this lesson, you will learn the basics of linear programming and how you can use your TI-83-84 calculator to help you solve these problems. The example used for this tutorial is to maximize p equals 40x plus 30y, subject to the conditions that x plus 2y must be less than or equal to 16, x plus y must be less than or equal to 9, 3x plus 2y must be less than or equal to 24, and x and y must both be greater than or equal to 0. Begin by entering the equations into the equation editor. Remember that the equations must first be converted to calculator-ready form. This means you must solve each equation for y. There are varying formats that can be entered into the equation editor. The format used in this example is y1 equals 16 minus x divided by 2, y2 equals 9 minus x, and y3 equals 24 minus 3x divided by 2. The next slides walk you through the process of entering the equations. You can just follow along with the keystrokes. You can see that the first line has now appeared in the graph view. Now you can see two lines in the graphing screen. You can press Graph to view the graphs now, or you can move directly to the Calc menu to start finding intersection points. You can use various techniques to find the intersection points of the lines and the areas where the lines intersect the axes. In this case, because all of the inequalities were less than or equal to, we know we are considering the area below all the lines. You should be able to identify the 5 points that mark the corners of the area, which is known as the feasible region. This lesson will show you how to determine those exact points. We will use the intersect function on the Calc menu to do this. First, recognize that we will only find the points needed, not all of the intersection points. This will require us to choose the correct lines for which to find the intersections. Sometimes it takes a few seconds for the graphs to appear. To see which line is the first curve, you can use the arrow keys to see which line you are on. This is the correct line, so press Enter. Again, you can use the arrow keys to see if the second curve is the one needed. It is the correct line, so press Enter. Press Enter again and you will get the first intersection point. The first intersection point we need is at 2, 7. You will do the same thing to find the second intersection point that is needed for this problem. Again, you need to head to the Calc menu. You can follow along with the keystrokes. The second intersection point is at 6, 3. Now we can use several different methods to find the intersection points with the axes. To find the intersection with the x-axis, you could use the table feature. Another option is to use the 0 function from the Calc menu. This is particularly useful when the 0 is not a whole number. Let's access the Calc menu again. This time we choose option 2, the 0 function. We need to make sure we are using the correct line. In this example, we need the line that crosses the x-axis nearest the origin, so we can see that we are not on the correct line. Use the up and down arrows to select a different line. You can use the left and right arrows to be sure you are on the correct line. That still wasn't the correct line, so use the down arrow again. You can use the left and right arrows again and see that you are now tracing the correct line. Also notice that the calculator is asking you for a left bound. In this case, the left bound must be above the x-axis, so move the cursor using the left and right arrows until you are to the left or above the x-axis. Once you are on the correct line and the cursor is above the x-axis, press Enter. Now you must select the right bound. In this case, that must be below the x-axis. Use the left and right arrow keys to move the cursor below the x-axis. Then press Enter. And press Enter again. Now you can see your 0, which occurs at 8, 0. The last point we need to find is the y-intercept. To find the intersection with the y-axis, it is often easiest to use the table feature. You can use the left and right arrows to look at the values of y when x equals 0. For this particular example, we know we want the lowest point, which in this case proves to be the point 0, 8. Now you have the final point needed for the linear programming problem.